Number 12 then from the specimen paper here. Proofs, 4 marks. Contrapositive doesn't crop up that often. Contrapositive is all to do with negations, and in fact that's part A. Given this statement here, state its negation for 1 mark. Well, the negation simply means whatever you say, you reply, no it's not, and say the opposite. So, M is even or N is even. Notice that doesn't imply that they're both even. That says N is even or N is even. There's a sort of implied either in front of that. So the negation of that would be M is even or N is even. No, it's not. Neither of them's even. So the negation would be neither nor. Either or, negation, neither nor. Neither M is even nor N is even. Whoops. But there are equivalent statements to that. Neither M is even nor N is even is the same as saying they're both odd. That's the same as saying M is, and put down the opposite, odd. Instead of or, it becomes and. N is odd. So either of those would do. Strictly speaking, that's the exact negation. The opposite of either or is neither nor. However, that's a more concise statement there. Maybe I'll just go for that one. And that was the first mark. Now, part B, by considering, so that means you've got to do it this way, by considering the contrapositive of the following statement. If Mn is even, then M is even or N is even. Prove that the statement is true for all positive integers M and N. That's just equivalent to saying, if you multiply 2 integers and the product is even, then one of them must have been an even number. But you're not to prove it directly, it says you have to use the contrapositive. Now the contrapositive is the reverse one. The converse simply means putting this statement first. If M is even or N is even, then the product Mn is even. That's the converse, you're not to use that. The contrapositive is using the opposite of this and the opposite of that in reverse. The contrapositive states that the negation of this should produce the negation of this, and it's logically equivalent to the original statement. So I'll write that down, contrapositive. The contrapositive is this. If you go to the second part of the statement and negate it, no it's not, so that's this one here. If M is odd and N is odd, then you've always got the 2 parts. You've got the if and the then. That's the statement itself. Putting that first and saying then this would be the converse. That's not what you're using. Stating the opposite of that, the negation of that, then the negation of that is the contrapositive. If M is odd and N is odd, then that's the negation of this part. The negation of that is then Mn, again it's a no it's not. Mn is even, no it's not. Mn is odd. That's what you have to prove. That's the statement of the contrapositive. Now that's the mark then for stating the contrapositive. Now you've got to do it. So what's this? How do we express this? If M is odd and N is odd, that means they're both odd numbers. So we'll do this. We'll let M be an odd number, so pick some letters. P, Q, A, B, I'll use A, B I think. So M would be 2A, whichever you want, minus 1. N has to be a different one. I don't want it to be a consecutive odd to this and say 2A plus 1. So I'll choose an entirely different letter, 2B minus 1. So if M is equal to that and N is equal to that, and of course importantly A and B would have to be these positive integers, the natural numbers. Then Mn would equal 2a minus 1 times 2b minus 1. Now you just have to multiply it all out. 4ab minus 2a minus 2b plus 1. You're trying to show it's an odd number. So that means you have to show it's an even number plus or minus 1. Well, there's a factor of 2 there. So it's 2ab minus a minus b plus 1. we shall say, which is an odd number. But again, just having 2 times something plus 1 doesn't guarantee it's an odd number unless that's an integer in there, since 2ab minus a minus b is still a member of the positive integers or the natural numbers. So now you've done that. This one first, contrapositive. If they're both odd, right, there we go. If that's odd and that's odd, then it should turn out that this thing is odd. So multiplying these odds, yes, I've got an odd. That's the second mark. Now for the third mark, it's just a case of stating that if the contrapositive is true, then that's logically equivalent to the original statement. The contrapositive is equivalent to the original statement, which means original statement is true. Lot of writing, yes. But that was the important thing about the contrapositive. The contrapositive is logically equivalent to the original statement. So proving that does instead of proving the original statement. There's the third mark.